Hi and welcome. In this video, we'll see another family of functions, namely the family of absolute value functions. The parent function for the family of the absolute value functions is y is equal to f of x is equal to the absolute value of x. Because of the absolute value, the range of the function f starts from 0 and runs up to plus infinity, while the domain of this function includes all real numbers. Let's start our exploration of absolute value functions by sketching the graph of the parent function y is equal to the absolute value of x, giving some values to x, and find the corresponding y values. X minus 2, y2, x minus 1, y1, x0, y0, x1, y1, x2, y2. Because of the absolute value, everything here is positive except 0, whose absolute value is 0. Putting these points on the two-dimensional space, we get the following graph for the function y is equal to the absolute value of x. As we can see, for x equal to 0, the function is 0. For other values of x being negative or positive, the graph of the function stays above x, x is therefore positive. The function is decreasing for all values less than 0, and the function is increasing for all values bigger than 0. The range, as we said, starts from 0 and runs up to plus infinity. We can apply all types of transformations to this parent function. For instance, let's start by shifting the function 2 units to the left and 3 units upwards. That is y is equal to f of x plus 2 and plus 3. This 2 is for the left shift, this 3 is for upwards, which is equal to the absolute value of x plus 2 plus 3. Let's name this as g of x. Then we expand g of x by a factor 1/2. Remember that we multiply 1/2 only with the x part, that is y is equal to 0.5. The absolute value of x plus 2 and plus 3. And let's denote this by h of x. Now let's find the x reflection of x, that is we multiply everything with negative 1. As a result, we get negative 0.5 times x plus 2 absolute value minus 3. Let's name this m of x, then find the y reflection of m of x, that is we replace x with minus x, and here as a result we get minus 0.5 absolute value of minus x plus 2 minus 3. Let's name this n of x. Now shift n of x 4 units to the right. For that, what we do is we add minus 4 here. As a result, we get minus 0.5 times x times the absolute value of minus x minus 2 minus 3, which is obtained by shifting the function n of x 4 units to the right. The general form of an absolute value function is y is equal to f of x c times the absolute value of ax plus b plus k, where c, a, b, and k are real constant numbers. Having the general form of the absolute value functions, let's try to identify all transformations present in this general form. For that, we start with taking a as a common factor. Inside, we get x plus b over a, absolute value, c and k remains the same. Then we take the absolute value of a, what we have inside is x plus b over a, absolute value plus k. And suppose that the absolute value of a is d, so we take the absolute value of a, which is d, c times d, times x plus b over a plus k. Then we multiply c and d, suppose that is t times x plus b over a plus k. Hence, what we have here is left or right shift by b over a, depending on whether b over a is positive or negative. We have upwards or downward shift by k units, depending on whether k is positive or negative. We have shifting or expansion by t units, depending on whether t is positive or t is between 0 and 1. For instance, consider y is equal to g of x minus 3 minus 2 times 4x minus 1 absolute value. What we do is first we take 4 as a common factor. We get 4 minus 1 over 4 absolute value. Then we take the absolute value of 4 outside, and that is 4 times minus 2 is minus 8 times x minus 1 over 4 absolute value. Then we take minus 1 outside as a common factor. We get 3 plus 8 times x minus 1 over 4 absolute value. And what we have here is, first of all, we have x reflection because of this negative sign. Second, we have upward shift by 3 units because of this 3. Then we have right shift by 1 or 4 units because of this minus 1 over 4. And we have shrinked by factor 8 because of this 8. Remember that what we do is we first apply all these transformations here, then finally we reflect it with respect to x axis. Thanks for watching and good learning.